In this section of chapter 4, I'd like to discuss about aqueous reactions. Aqueous means reactions happening in water solution, then electrolytes, non-electrolytes, and spectator ions. First, let me define what solution is. Solutions are defined as homogeneous mixture of two or more substances. Homogeneous means when you mix them together, you'd not be able to know whether two substances are together. In other words, they make a single phase. Phase means bounding surface. So when you add sugar in water or salt in water, you'd not be able to know whether sugar is there or salt is there. Normally, solvent is the substance that is present in greatest abundance in a solution, and other substances are called solutes. Like when you add sugar in water, water is in large excess, that's solvent, and sugar is in relatively smaller quantity, and that's solute. In the figure on the left, you're looking at how sodium chloride or table salt goes in water solution. Basically, water molecules get attracted to these different ions, sodium plus and Cl minus, and they pull those ions from the solid, and then water molecules surround both sodium plus and Cl minus, and that's how they go in water solution. The whole process is called dissociation, and we use the word solvation when water molecules surround these sodium plus and Cl minus ions. Now we're going to define what electrolyte is. So electrolyte is a substance that dissociates in ions when dissolved in water, and they pass readily electricity. Non-electrolyte, they can dissolve in water, but it doesn't dissociate into ions. Like when you add sugar in water, sugar doesn't dissociate. And electrolytes, as I mentioned to you, they allow electricity to pass through quite readily. Non-electrolytes don't show much tendency to pass electricity. Strong electrolytes are usually strong acids, strong bases, or salt solutions which dissolve in water and form ions. Weak electrolytes are weak acids, weak bases. They break down only partly. Out of 100, maybe 4 or 5 of them would break down. So that's why they don't contribute much towards electrical passage. All other compounds are non-electrolyte. That means they don't help in the passage of electricity. Now here we are showing you some experiments, and you can see that how sodium chloride solution allows electricity to pass through, because sodium chloride breaks down into sodium plus Cl minus. In the middle section, sucrose is added. Sucrose is nothing but table sugar, and you can see that the light is not on. Same is the case with pure water. The bulb didn't turn on because it's not passing electricity to the extent needed to light the bulb. So strong electrolyte, sodium chloride, dissociates completely when dissolved in water, and that allows electricity to pass through quite readily. Weak electrolytes like organic acids only dissociates partly, and non-electrolytes do not dissociate when dissolved in water, and that's why conductivities are so different. Here we're writing down all the types of substances that could be strong electrolytes, like strong acids, strong bases, because they ionize completely. Same is the case with soluble ionic salts like sodium chloride, potassium chloride. So these are ionic salts. Now about the strong acids, you can see that some of the acids are shown here. Precipitation reaction. Quite often, if you add two different solutions, they look clear, but when you add them together, you see nicely colored compound that separates. What is happening there? Because of the reaction, you get a product which is not soluble in the solvent. So in this case, if we are showing you water solution, then the product doesn't go in solution, then it settles down as a precipitate. Now that it could be colored, it could be white, but you should be able to see it. In this slide, we are showing you metathesis or double displacement reaction, and we have shown you molecular equation because we haven't shown you how they're going to break down or which of them would break down in water solution. Let me figure out that quickly. This is how you are going to figure out. If there is a metal in the compound, and if you see AQ there, this is AQ, aqueous solution, separate the metal from the other part of the compound. So I'm going to separate these as silver plus aqueous, because that's how metallic compounds go in water solution. And I'm going to write down plus NO3 minus aqueous. Now the next compound is KCl aqueous. Again, it's the same thing. You're going to split that into K plus and Cl minus because it has gone in aqueous solution. Let me write down that. Again, since I don't have enough space, I'm going to write down the bottom AQ plus Cl minus AQ. On the right hand side, which is the product side, you see silver chloride shown in parentheses as solid. That means it's insoluble. That means water does not break down silver plus from Cl minus. So keep it as it is. So write down silver chloride as a solid. Now KNO3 shown as aqueous. Again, since aqueous means it has gone in water solution, so it has to break down. So K plus aqueous plus NO3 minus aqueous. So that's going to be the first step before you write an ionic reaction, and then you identify what we call a spectator ion. In next slide, we're going to show you that. I have already discussed how you break down those compounds. So this is the equation that I have already explained to you. Now, in order to get the spectator ion, you need to look at both left-hand side as well as the right-hand side. Find out whether you have same thing on both places, on both sides. I have NO3 minus on the left-hand side. I have NO3 minus on the right-hand side. And these are called spectator ions. That means they don't participate in the chemical reaction. When they're present on left-hand side, on reactor side, as well as on the product side, that means that nothing had happened to those ions. Same is the case with K plus. So you have K plus on left-hand side, K plus on the right-hand side. That means they're not really participating in the reaction. If they took part in the reaction, you're not going to get K plus on the reactant side as well as K plus as product. On the other hand, silver plus and Cl minus, let's underline them. They are not spectator ions because on the right hand side, you don't have separated silver plus and Cl minus. Rather, you have silver chloride. So, after cancelling out spectator ions or ions which do not take part in the reaction, you end up with this ionic equation, which you have silver plus aqueous plus Cl minus aqueous, giving silver chloride solid. So that's the net ionic equation or net ionic reaction.